Hello Internet, I'm Guy, and this is an ultrasonic levitator that I built from this kit that I found on the web. I'll put a link to it below. So it's fairly complicated to assemble. I'm an electronics engineer with about 50 years of experience assembling tiny little parts. And while the kit says it's okay for beginners, it's definitely not. These parts, as you can see, are microscopic, and I'm very good at assembling circuit boards this size, but I wouldn't recommend this for anyone who isn't. But as you can see, I'm meticulously following the instructions. That's very important with kits like this. Some of these parts are the size of a grain of sand, as you can see. They're really tiny, but I'm used to it. So here I'm getting into the final physical assembly, the mechanical parts, just putting the screws and the standoffs together that are incidentally calibrated to a wavelength of the ultrasonic sound. So here we are. I'm going to try it out, plug it in. Two little lights come on. That's a good sign. Now I'm going to take some of these little styrofoam balls that come with the kit and using tweezers just place them right in there. It worked first time. It's really impressive. Nicely designed kit, and it will hold 4 stably if you just place them really carefully. One of the issues with these styrofoam balls is they have a lot of static charge to them, so it's hard to get them separated and control them. But look at that, it'll actually work sideways too. Isn't that amazing? Science in action. So now I'm just going to turn the power off and boom, that's what happens. Now I thought I'd try setting it up upside down, and gravity is not really having an effect. The electrostatic qualities of the little styrofoam balls are definitely an issue, but I can get all 4 of these back in place upside down. It's just not affected by gravity. It's stuck to the tweezers. Yeah. I have a static discharge tool that I'm going to use on these to prevent that from happening. So now I've decided, as you might have seen at the very beginning, to put some little blue lights in there to light the balls. So I'm on the mill here, getting centered up on the bottom ultrasonic transducer. Got the back there done, and now working on the front edge. Bump that in until it centers. There we go. So I'm using a 0.03 inch PC board drill here to make a couple of holes for the LEDs. I did, of course, double check that these holes would not impact any of the circuits on the other side of the board. In retrospect, I probably should have supported the circuit board a little bit better, but these tungsten carbide PC board drills go right through it. So here are the blue LEDs. One of them will drop in there, and this is a tester just to show that it lights up really nicely. So I'm using blue heat shrink tubing here to stop all of the edge light from blinding you when you're looking at this thing. So that'll focus the LED so you just see the beam of light, or the beam of light just focuses on the little balls that are floating there. So I'm using my heat gun here to shrink that down, making like little miniature spotlights essentially. So I've got the LED installed in the holes, and I'm tinning the leads, which means just adding some solder onto there. There's a hemostat gripped onto them to absorb the heat, basically as a heat sink. And I'll just attach these 2 tiny little wires. This is actually wire wrapping wire, if those of you are familiar with that. So then I'm going to tag those down to the LEDs that I had previously removed. Now I'm going to use this really interesting new adhesive that I discovered called Bondic. It's kind of derived from a dental material, and it's ultraviolet curing. So once you put a glop down there, almost like you would do with any epoxy adhesive, you use this little tiny ultraviolet light that comes with the kit, and 4 seconds later that stuff is completely hardened. It's quite amazing. I usually give it a few extra seconds just to be sure, but they say 4 seconds is fine, and there it is, quite solid. So I'm just going to do the other one here. As you can see, it's a little dispenser like a syringe basically, and as long as you don't expose it to UV light, it won't seize up. So I would definitely not leave the cap off if UV light in the sunlight would cause it to seize up. So there we go. Really neat adhesive. I'll put a link to this below. So once again, testing just to make sure everything's good. Those lights now work beautifully and light the ball, and It works with the clear acrylic cylinder, but I'm noticing that it's a little less stable, it seems. There's something going on acoustically inside the cylinder. So for the cylinder, I need to drill a hole for the power jack, which is what I'm measuring there from the bottom of the foot to the center line of the power jack, 0.510 inches. I've got my center finder all set up, and I'm just going to find that left edge. And there it is. So now I'm using a 1/4 inch plastic drill that has a long taper. If you use a regular drill, it'll bite when it goes through the bottom edge of acrylic. So you should use a acrylic drill. Now I'm going to use a step drill here to get it bigger. This is one of the new aftermarket secondary market drills. The original company that started these step drills back 40, 50 years ago was called Irwin, and I still prefer some of their drills, but these new ones are really quite good too. This is my original Irwin that goes 1/4 to 3/4 here. Now I'm drilling a hole here so I can reach into with the tweezers to place the balls once this cylinder is covering the whole thing. This is the biggest one I have that goes up to, I believe, 1.25 inches. And it makes a really beautiful finished hole on acrylic. So now I'm making the base. So I've cut it out on the bandsaw roughly, and I'm just turning it down to get it circularized and cleaned up. I have it mounted to a 1/4 by 20 bolt with a nut tightened down onto the acrylic here. That's a nice finish. That round nose cutter is ideal for acrylic. So I also cut a bevel on it that you didn't see. It's the top edge. Dropping my center finder in there now. And I'm just going to drive over to center. There we go. So now I'm using a small drill for 256 clearance, because that's what the size of the screw is that goes into the standoffs in the base. You notice I flipped it over, and I'm just checking my head size there, so I now need to drill a clearance for the head in the bottom. Dropping that mill in there. That's a 2-flute cutter, which is ideal for acrylic. Checking that it will fit, bottoms out nicely. So now I've got that bolted on there, and now the cylinder can drop right over, and the hole will line up with the charging jack eventually there. Now what I'm going to do is basically weld the cylinder to the base. The adhesive I use is known as Weld-On, and what happens here is when you infuse this liquid into the joint there, it fills the joint by capillary action and will set very quickly, but it doesn't actually glue, it actually welds. That means that both pieces of plastic that are in contact with the glue here, well, not really glue, bonding agent, basically they dissolve into each other in the same way that a metal welding process would happen. Plastic basically welds. That's the applicator there. It's like a little syringe that you can squeeze. So now I'm going to cut a piece for the top. I'm going to make a lid. Marking that off, and then I'm going to cut it out on the bandsaw. This is another substantial chunk of black opaque acrylic. Putting it up on the lathe here. So now I'm going to turn down the interior diameter. The part will fit into the top of the cylinder. I'm going to have to stop and check fairly often here to get my dimension right. So I'm going to drop in just a loose cut-off piece that I have of the tubing. It's just easier to get it in there. Might as well take that paper out of there now. You know, empirical fit method here. And I'm getting really close now. I'm down to the last couple of thousandths. That's almost there. Yep, 1 or 2 more passes. It's a very iterative process. There it goes. That's a perfect fit, a nice interference fit. So now I'm going to flip it over and grip it in the jaws. Not shown here. I later went back in and put a couple of parallels behind it to bump it away from the jaws just enough that I could machine right down to the bottom edge of the acrylic there. So here I am coming in there, And it's very tight tolerances. It was a little nerve-wracking to set that up. But now I'm trying to match the OD of the cylinder here. Looking good. So there's the assembly. There's also an interior sheet of acrylic right below the balls there. So the whole point of this lid was to store the balls so I can have some available, because I'm sure I'll end up losing them. So there we go. I can use the tweezers and place it right there. What's interesting, though, the balls aren't perfectly in the center, and what's going on is there's an acoustic interference from the cylinder that is preventing the balls from lining up dead vertically. You can see one of them on there is offset to the right quite a bit. So that was an unanticipated, I guess, a benefit? I don't know. It makes them more interesting to look at. You can see them floating there. Now it's a little confusing because there are reflections from the lights on the walls. But what a cool toy. I had so much fun making this. I hope you've enjoyed this video, and if you have, please give me a like and subscribe. And if you want to support me, you can find the Patreon link down in the description below.